Australia is a continent situated on the Indo-Australian Plate. The geology of Australia includes virtually all known rock types and from all geological time periods spanning over 3.8 billion years of the Earth's history. Components. Australia's geology can be divided into several main sections: the Archean Cretaceous shields, Proterozoic fold belts and sedimentary basins, Phanerozoic sedimentary basins, and Phanerozoic metamorphic and igneous rocks. Australia as a separate continent began to form after the breakup of Gondwana in the Permian, with the separation of the continental landmass from the African continent and Indian subcontinent. Australia rifted from Antarctica in the Cretaceous. The current Australian continental mass is composed of a thick subcontinental lithosphere, over 200 kilometers thick in the western two-thirds and 100 kilometers thick in the younger eastern third. The Australian continental crust, excluding the thinned margins, has an average thickness of 38 kilometers, with a range in thickness from 24 kilometers to 59 kilometers. The continental crust is composed primarily of Archean, Proterozoic and some Paleozoic granites and gneisses. A thin veneer of mainly Phanerozoic sedimentary basins cover much of the Australian land mass. These in turn are currently undergoing erosion by a combination of aeolian and fluvial processes, forming extensive sand dune systems. Deep and prolonged development of laterite and saprolite profiles, and development of playa lakes, salt lakes and ephemeral drainage blocks. The main continental blocks of the Australian continent are the Yilgarn Craton of Archean age, the Pilbara Craton of Archean to Proterozoic age, the Gawler Craton and Wildayama Block of Archean to Proterozoic age. These are in turn flanked by several Proterozoic orogenic belts and sedimentary basins, notably the Musgrave Block of granulite, gneiss and igneous rocks, the Aronda Block of amphibolite-grade metamorphic rocks and granites, the Gascoyne Complex, Glengarry Basin, and Banghamel Basin sandwiched between the Yilgarn and Aronda blocks. Geologic history. The geologic history of the Australian continental mass is extremely prolonged and involved, continuing from the Archean to the Rhiestland. In a gross pattern, continental Australia grew from west to east, with Archean rocks mostly in the west, Proterozoic rocks in the center, and Phanerozoic rocks in the east. Recent geologic events are confined to intraplate earthquakes, as the continent of Australia sits distant from the plate boundary. The Australian continent evolved in 5 broad but distinct time periods, namely 3800–2100 Mar, 2100–1300 Mar, 1300–600 Mar, 600–160 Mar, and 160 Mar to the present. The first period saw the growth of nuclei about which cratonic elements grew, whereas the latter 4 periods involved the amalgamation and dispersal of Nuna, Rodinia and Pangaea, respectively. Tectonic setting. The Australian land mass has been part of all major supercontinents, but its association with Gondwana is especially notable as important correlations have been made geologically with the African continental mass and Antarctica. Australia separated from Antarctica over a prolonged period beginning in the Permian and continuing through to the Cretaceous. Continental Australia is unique among the continents in that the measured stress field is not parallel to the present-day north-northeast directed plate motion. Most of the stress state in continental Australia is controlled by compression originating from the 3 main collision boundaries located in New Zealand, Indonesia and New Guinea, and the Himalaya. South of latitude -30 degrees, the stress trajectories are oriented east-west to northwest-southeast. North of this latitude, the stress trajectories are closer to the present-day plate motion. being oriented east-northeast, west-southwest, and northeast-southwest. Notably, the main stress trajectories diverge most markedly from one another in north-central New South Wales, although the area is not known historically for earthquake activity. Young mountain building in the Flinders Ranges of South Australia is driven from plate convergence at the boundary in New Zealand. Australia is currently moving toward Eurasia at the rate of 6 to 7 centimeters a year. Archean. There are three main cratonic shields of recognized Archean age within the Australian land mass: the Yilgarn, the Pilbara, and the Gawler cratons. Several other Archean Proterozoic orogenic belts exist, usually sandwiched around the edges of these major cratonic shields. The history of the Archean cratons is extremely complex and protracted. The cratons appear to have been assembled to form the greater Australian land mass in the late Archean to Mesoproterozoic. Chiefly the Capricorn orogeny is partly responsible for the assembly of the West Australian land mass by joining the Yilgarn and Pilbara cratons. The Capricorn orogeny is exposed in the rocks of the Banghamel Basin, Gascoyne Complex granite gneisses, and the Glengarry, Yerrada, and Padbury basins. Unknown Proterozoic orogenic belts, possibly similar to the Albany Complex in southern Western Australia and the Musgrave Block, represent the Proterozoic link between the Yilgarn and Gawler cratons, covered by the Proterozoic, Paleozoic Officer and Amadeus basins. See also, Narre gneiss terrain, Paleoproterozoic Western Australian events. The assembly of the Archean Yilgarn and Pilbara cratons of Australia was initiated at tilde 2200 Ma during the first phases of the Capricorn orogeny. The last stages of the 2770-2300 Ma Hamersley Basin on the southern margin of the Pilbara craton are Paleoproterozoic and record the last stable, submarine fluviatile environments between the two cratons prior to the rifting, contraction and assembly of the intracratonic tilde 1800 Ma Ashburton and Blair basins, the 1600 to 1070 Ma Edmund and Collier basins, the 1840 to 1620 Ma Northern Gascoyne complex, the 2000 to 1780 Ma Glenborough terrain in the southern Gascoyne complex, and the Erebidi shear zone at the northwestern margin of the Yilgarn craton, between approximately 2000 to 1800 Ma on the northern margin of the Yilgarn craton, the c. 1890 Ma Narracoothar volcanics of the Briar Basin formed in a transverse back arc rift sag basin during collision. Culmination of the cratonic collision resulted in the fallen sedimentary Padbury Basin. To the east, the Yerrada and Irahidi basins were passive margins along the Yilgarn's northern margin. The c. 1830 Ma phase of the Capricorn orogeny in this section of the Pilbara-Yilgarn boundary resulted in deformation of the Briar-Padbury Basin and the western fringe of the Yerrada Basin. Along with flood basalts, the Yapunku orogeny formed the Stanley Fold Belt on the northern margin of the Irahidi Basin. Via assembly of the Archean Proterozoic fold belts of northern Australia. East Australian events. The Paleoproterozoic in southeastern Australia is represented by the polydeformed high-grade gneiss terrains of the Wilyama supergroup, O'Larry Block and Broken Hill Block, in South Australia and New South Wales. The Paleoproterozoic in the north of Australia is represented mostly by the Mount Isa Block and complex fold thrust belts. These rocks, aside from suffering intense deformation, record a period of widespread platform cover sedimentation, enzialic rift sag sedimentation including widespread dolomite platform cover, and extensive phosphorite deposition in the deeper seabeds. Mesoproterozoic. The oldest rocks in Tasmania formed in the Mesoproterozoic on King Island and in the Tainan Block. Late Mesoproterozoic igneous events include the Giles Complex Mafic-Ultramafic intrusions in the Musgrave Block at tilde 1080 Ma, widespread sills in the Banghamel Basin and the Glenelg area at tilde 1080 Ma. The Warkan, a large igneous province of tilde 1080 Ma. Neoproterozoic widespread deposition occurred in the Centralian Superbasin and Adelaide geosyncline during the Neoproterozoic. The Peeterman Orogeny caused extensive uplift, mountain building and basin fragmentation in Central Australia at the close of the Neoproterozoic. Paleozoic Cambrian. The Staveley Zone in Victoria is a boninite to Morb basalt terrain considered to have been connected with the boninites, the Mount Reid volcanics of northern Tasmania. In New South Wales, extensive deepwater sedimentation formed the Adaminaby beds in Victoria and New South Wales. The Lachlan Fold beltophyllite sequences are considered to be of Cambrian age, and are obducted during the Lachlan Orogen. The Peeterman Orogeny in Central Australia, which started at the end of the Neoproterozoic, continued into the Cambrian, shedding a thick intercontinental sequence of fluvial sediments into the Central Australian land mass. Marginal platforms and passive margin basins existed in South Australia, formed in the foreland of the Delamerian Orogeny. Western Australian passive margin basins and platform cover begin at this stage. The extensive Antrim Plateau flood basalts, covering in excess of 12,000 square kilometres, erupt in the Cambrian of Western Australia, providing a useful chronostratigraphic marker. Stansbury Basin, Gascoyne Sub-Basin, begins Cambrian, through to Tertiary. Bonaparte Gulf Basin, Ordovician. Ordovician geological events in Australia involved alpinotype orogeny in the Lachlan Fold Belt, resulting in the Great Serpentinite belts of western New South Wales, and accretion of deepwater Malassian flysch exemplified by the slate belts of Victoria and eastern New South Wales. Victoria 490 to 440 Ma. The late Cambrian to early Ordovician saw deep-water sedimentation of the Santano and Castlemaine group turbidites, which are now emplaced in the Stawell and Bendigo zones. The Middle Ordovician saw the deposition of the Sunbury group in the Melbourne zone, Bendock group, and formation of the Molong Arc, a calcaline volcanic arc which is related to the Kiandra group turbidites. Ordovician orogenies include the Lachlan Orogeny, Silurian. During the Silurian period, most of the Australian continent in the west and centre was dry land. However, from Geraldton north to Exmouth Gulf along the far western Australian coast, a fluvial sediment basin existed. Near Kalbarri on the Murchison River, the footprints of a giant water scorpion were found on land, the first animal to walk on the Australian continent. A gulf linked to the sea existed under what is now the Great Sandy Desert. Meanwhile, in the east there were volcanic arcs in New England, also west of Townsville and Cairns, and in NSW and Victoria and the Australian Capital Territory. Deep water sediments formed in the Carruchumit and Ilan troughs. The Yarth-Molong Rise was a row of volcanoes. Granite intrusions formed in New South Wales and Victoria from 435 to 425 Ma, with the Bega batholith as young as 400 Ma. In NSW granites, the distinction between I-type and S-type granites was discovered. Devonian. During the Devonian period, conditions were warm in Australia. There was a large bay in the Great Sandy Desert with reefs. The Calliope Arc went from the north of Rockhampton south to Grafton. Most of the centre and west of Australia was land mass. There were volcanic mountains off the current east coast supplying sediment into a basin on parts of the east. The basin contained limestone and river-deposited sand. Andesite and rhyolite volcanoes were found in central NSW, the Snowy Mountains, Eden, New England and near Claremont, Queensland. Barraguanathia longifilea was the first Australian land plant appearing at this time. The Peeterman Orogeny compressed the eastern seaboard in an east-west direction, with Tasmania, Victoria and southern New South Wales folded 385 to 380 mi. Northern NSW and Queensland was compressed 377 to 352 mi. A major river drained the continental interior and passed eastwards at Parkes. The Bungle Range sandstone was formed in Western Australia from river sands. More granite was intruded in the Devonian. The Connors Arc and Baldwin Arc formed behind Mackay and western New England. Carboniferous. The Carboniferous period saw the eastern highlands of Australia form as a result of its collision with what are now parts of South America and New Zealand. At the time they were formed, they are believed to have been as high as any mountains on the planet today, but they have been almost completely eroded in the 280 million years since. Another notable feature of Carboniferous Australia was a major ice age which left over half of the continent glaciated. Evidence for the cold conditions can be seen not only in glacial features dating from this period but also in fossil jelly soils from as far north as the Hunter River Basin. Mesozoic, Permo-Triassic. The Permian to Triassic in Australia is dominated by subduction zones on the eastern margin of the land mass, part of the Hunter-Bowen orogeny. This was a major arc accretion, subduction and back arc sedimentary basin forming event which persisted episodically from approximately late Carboniferous in its initial stages, through the Permian and terminated in the Middle Triassic at around 229 ma to 225 ma. In Western and Central Australia, the then extensive Central Australian mountain ranges such as the Peeterman Ranges were eroded by the Permian glacial event, resulting in thick marine to fluvial glacial tillite and fossiliferous limestone deposits and extensive platform cover. Rifting of Australia from India and Africa began in the Permian, resulting in the production of a rift basin and half-grabens of the basal portions of the long-lived Perth Basin. Petroleum was formed in the Swan Coastal Plain and Pilbara during this rifting, presumably in a rift valley lake where the bottom was deoxygenated. See also Perth Basin, Bowen Basin, Gunnedah Basin, Sydney Basin, Ipswich Basin, Clarence Morton Basin. Jurassic. In the west of Australia, the Jurassic was a tropical savanna to jungle environment, shown by advanced tropical weathering preserved in the regolith of the Yilgarn Craton, which is still preserved today. Australia began rifting away from Antarctica in the Jurassic, which formed the Gippsland Basin, Otway Basins in Victoria and the offshore shelf basins of South Australia and Western Australia, all of which host significant oil and gas deposits. Jurassic coal-bearing basins were formed in north-central Queensland, with significant marine platform cover extending across most of central Australia. Continued passive margin subsidence and marine transgressions in the Perth Basin of Western Australia continued, with the Jurassic Katamara coal measures a notable fluvial terragenous formation of the Jurassic. See also Surat Basin, Perth Basin, Cretaceous. The initial rifting of Australia and Antarctica in the Jurassic continued through the Cretaceous, with offshore development of a mid-ocean ridge seafloor spreading center Tasmania was rifted off during this stage. Cretaceous volcanism in the offshore of Queensland was related to a minor episode of arc formation, typified by the Whitsunday Islands, followed by development of offshore coral platforms, passive margin basins and far-field volcanism throughout the quiet Hunter-Bowen orogenic belt. Cretaceous sedimentation continued in the Surat Basin. Some small Cretaceous volcanism was present at the edges of basement highs in the Great Artesian Basin, resulting in some sparse volcanic plugs today. Cretaceous sedimentation continued in the Perth Basin. Paleocene to Eastland, the Tertiaries or the majority of Australian tectonism cease. Sparse examples of intraplate volcanism exist, for instance the Glasshouse Mountains in Queensland, which are tertiary examples of a chain of small volcanic plugs which decrease in age to the south, where they result in 10,000-year-old Mar volcanoes and basalts of the newer volcanics in South Australia and Victoria. Geology maps, mines and mineral deposits 1.3 megabits PDF. See also, by state and territory, Geology of the Australian Capital Territory, Geology of Tasmania, Geology of Victoria, Category, Geology of Western Australia. See also, by feature, Adelaide geosyncline.